All right, we're looking at the second practice question right up here. And it says, steam has been admitted to a main condenser for 25 minutes with no cooling water flow. Yeah, this is definitely not a good thing, right? We always want to admit the cooling water first, then the hot fluid, and in this case, we haven't. So the question is, initiating full cooling water flow rate at this time will? Well, that's going to be a pretty significant thermal stress on this condenser, especially the tube sheet. So let's see which ones say that. It'll reduce the stress on the condenser shell by rapidly cooling it. No, it's going to induce a pretty large thermal stress here, so not alpha. Let's look at Bravo. Reduce the stress on the tube sheets by rapidly cooling the tubes? No, this is a huge thermal stress. It's going to possibly crack some welds. So let's see what this is. Induce large thermal stresses on the condenser shell. That's not what's experiencing the large thermal stresses. Let's see what it is. Induce large thermal stresses on the junctions between the condenser tubes and the tube sheet. And this is where the actual stress is going to be. See, if we were to blow this up, you have steam coming down, and here's the actual tube sheet right here in the condenser, and there's holes in it, obviously. And then the tubes go like this, and they go to another tube sheet on the outlet side. And obviously, I can't draw this three-dimensionally like I wish I could. But when that steam's been going to it, and then you rush cold water through the tubes, right here, these welds, these tube-to-tube sheet welds right here in the corners, real susceptible to just thermally induced cracks. So delta is the best answer here.